Okay, so today we're going to talk about statements and more importantly, conditional statements. So let's do, so typically statements are represented by single letters such as P and Q. So we usually in math we represent whole sentences as or whole statements as P and Q. Let me just do what a conditional statement is, and then we can do an example. So a conditional statement or statements are statements of the form if P, then Q. And in math, this is written as P implies Q. Okay. In these statements, we have what is known as a hypothesis and a conclusion. Okay. So for the statement, if P, then Q, P, the statement P is what is called the hypothesis. Okay? And Q, the statement Q, is called the statement's conclusion. So its conclusion. So the statement's conclusion. Okay? So let's do an example of this. So let's have the statement. So here's an example. So if it is raining, oh, raining. I don't know how to spell raining. Let me fix that. Raining. Okay. Then the street is wet. Okay. So P would be the statement, it is raining, right? Because that's the hypothesis. Man, I always want to do that weird ring or whatever. Raining. And this is what's known as the hypothesis of that statement. Okay? And then Q would be the statement, the street is wet. And this is what's known as the conclusion of the statement. All right. So now let's talk about converse of a conditional statement. So let's say we have a conditional statement, P implies Q, right? So the converse would just be Q implies P. The inverse of P implies Q would just be not P implies not Q. And this is just not or the negation. Okay? So if the statement P was like, it is raining, then not P would be, it is not raining, right? That's pretty much it. So that's that not, or it's called negation as well. Okay? So now contrapositive of P implies Q. Now this one's going to be not Q implies not P. Okay, so let's just do an example to help us out construct these other statements. Okay, so let's say we have the statement if A, B, C, D is a square, then it has 4 right angles, right? And ABCD is just a geometric figure. We're calling it a square. If we were to draw this, right, intuitively speaking, we have A, B, C, D, and if it were a square, we would have these 4 right angles, right? Does that make sense? We would have that. Okay, so that's A, B, C, D. But we don't want to determine the validity of the statement. We just want to know how to do the converse and all that other stuff. So P would be what? A, B, C, D is a square, right? A, B, C, D is a square, right? And Q would be A, B, C, D has 4 right angles, right? Because up here it says it, but it's referring to A, B, C, D, right? This geometric figure. Okay, so the converse, right? So remember, converse is Q implies P, right? So the converse would be A, B, C, D has 4, oh, I'm sorry, if, right? If A, B, C, D has 4 right angles, then it is a square, right? So that's how we would do the converse of our statement P implies Q. It would be Q implies P. Now let's do the inverse. And remember, the inverse is not P implies not Q. So the inverse would be if ABCD is not a square, then it does not have 4 right angles. Okay, so that's how we would write the inverse of this statement. Okay, now let's do the contrapositive. Okay, remember the contrapositive is not Q implies not P. Okay, so if A, B, C, D does not have 4 right angles, then it is not a square. Okay. So the main thing with these is you got to memorize, or you got to learn that the where are they? The converse of P implies Q is Q implies P. The inverse of P implies Q is not P implies not Q. And the contrapositive of P implies Q is not Q implies not P.